we have seen what is a sequence and what is a series. Now there are various kinds of sequences. Mainly we will study a sequence called arithmetic sequence, or it is also called arithmetic progression. Second is geometric sequence or geometric progression. Third is harmonic sequence or harmonic progression. There is one more which is called arithmetico-geometric sequence or arithmetico-geometric progression, that we will see later. Initially, we will focus on arithmetic progression or arithmetic sequence. Now, what is an arithmetic sequence? Let's see. If I consider one example, say 1, 4, 7, 10, 13, ... This is a sequence. Now, the difference between 4 and 1 is 3. The difference between 7 and 4 is again 3. The difference between 10 and 7 is again 3. And the difference between 13 and 10 is again 3. So, difference between any two consecutive terms, any term minus its preceding term, remains constant 3, 3, 3, 3 and 3. Such kind of sequence where the difference of any two consecutive terms, next term minus preceding term, remains constant is called an arithmetic progression. So, this difference which remains constant is called what? The common difference of the arithmetic progression. So, if I consider a sequence, say A1, A2, A3, A4, ... somewhere an ... This sequence will be called an AP. AP means arithmetic progression. If A2 minus A1 is same as A3 minus A2 is same as A4 minus A3 is same as ... an minus its preceding term is what? An minus 1. This continues. And this difference is constant throughout. Let us denote it by what? D, called common difference of this NAP. So, if we are given, you know that a sequence can be represented by putting its nth term in a bracket. So, suppose this sequence is represented by bracketed an. So, A1, A2, A3, A4, an ... is called an AP arithmetic progression if this an minus an minus 1 remains constant, say D, for all n equal to 2, 3, 4 onwards. So, difference between an and an minus 1 means difference between any two consecutive terms of the sequence remains constant is called what? AP. If I put n equal to 2 over here, I get A2 minus A1. That is this. If I put n equal to 3, I get A3 minus A2. That is this. If I put n equal to 4, I get A4 minus A3. That is this. So, in general, this difference remains constant for all natural numbers 2, 3 onwards, because initially we are writing the next term minus preceding term. So, n has to be taken 2. So, if this difference remains constant, then this sequence bracketed n is called what? An AP. If this is the AP, then we can generate AP by writing the first term. Suppose A is the first term. We know by adding 3 to 1, I am getting 4. By adding 3 to 4, I am getting 7. By adding 3 to 7, I am getting 10. So, once the first term is known and we decide some number which is to be added constantly throughout in the sequence, suppose that is what? D. Then the AP can be generated as follows. Suppose the first term is what? A. The next term would be what? A plus D. The next term would be what? A plus 2D. Next term would be what? A plus 3D. Likewise, we go on and on to form the arithmetic progression. So this is the first term, second term, third term, fourth term. So suppose this is the fourth term. Suppose this is the third term. So when I write A4, fourth term, I see that A and D, everywhere they are there. But when this is 4, this here I am writing what? 3. When this is 3, here I am writing what? 2. When this is 2, I am writing 1. And when this is A1, I am writing A plus 0D. So, whichever is the suffix of A, one less we are writing as a coefficient of what? D. So, suppose if I want to find the nth term of an AP, then it must be A plus n minus 1 into D. So, 1 is less. So, n minus 1. From this n, we are subtracting 1 to write that as a coefficient of what? D. So, nth term of an AP is given by A plus n minus 1 into D. A is the first term, D is the common difference, and whichever suffix you write over here, reduce 1 from that to write that as a coefficient of what? D. So, in general, nth term of an AP is given by A plus n minus 1 into D. So, this is the important formula to find the nth term of an what? AP. So, this way we have defined what is an AP. Now, let us go ahead to find the sum of the first n terms of the AP. Means, if suppose this is your AP, A plus D, A plus 2D, A plus 3D, dot, 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 A plus n minus 1 into D. So, if I want to add these all n terms of the AP, then what is the sum in a compact way, in a formulaic way, so that we will try to put in one formula, right? So, let us find out the sum of the first n terms of AP. So, we know that the notation for the sum of the first n terms is Sn, S for sum, n for number of terms. So, first n terms of AP. So, first n terms of AP means what? A plus D. This is the first term, this is the second term. A plus 2D, dot, dot, dot. Somewhere here you are writing A plus n minus 1 into D. This is the nth term. So, this sum I want to add to write a single term. Now, to do this, the idea is as follows. Let me call first of all A plus n minus 1 into D is some number L. Now, observe that I can write Sn as A plus D plus A plus 2D plus dot, dot, dot. Plus what is this I called n. The preceding term of any term in AP can be obtained by subtracting D, common difference. From that, what I get? A plus 2D. What is the preceding term? A plus D. How? Reduce D from this. 2D minus D is D. So, A plus D is left. Likewise, the preceding term of L is what? L minus D. Its preceding term is what? L minus 2D. So, this way I am writing the sum of the first n terms of this Sn. Now, to get this Sn in a compact way, what we do, the technique is write this sum in the reverse way. Writing the sum in the reverse way does not change its value. Hence, let me write this as Sn. The last term would be written as the first term. The second last term would be written as the second term. The third last term would be written third term. Plus, likewise, we go on and on. The first term would be the last term. Second term would be the second last term. And third term would be the third last term. So, I am writing the same sum in the reverse order. Now, what we do is, we simply add the corresponding terms of this series. Sn plus Sn is twice Sn. Now observe that I am adding corresponding term, this, then this, then this. This way we will proceed. So A plus L is the first addition. Next, if we add these two, this D and this minus D will get cancelled, and I will get again A plus L. So here if I add these 2D minus 2D is cancelled, again I am getting A plus L. So this A plus L, the sum, same number, is repeating how many times? First time, second time, third time, and this is what? Nth time. So this will continue and I will get A plus L, A plus L, A plus L. How many times? N times. So 2Sn becomes A plus L N times, means it is N times A plus L. So Sn is given by, therefore, N by 2 into bracket A plus, what is L? L is the nth term given by A plus N minus 1 into D. So this is A plus N minus 1 into D. So this is nothing but N by 2 into bracket A plus A I can add to get twice A plus N minus 1 into D. So this way the formula for Sn is known, which represents what? The sum of the first n terms of an AP. So if A is the first term, D is the common difference, and N is the total number of first n terms we are adding, that N, then Sn is given by what? N by 2. How many terms we are adding? N. So N by 2 into bracket twice A, 2 times first term, plus it's the same number N you use here, N minus 1 into what? The common difference. So the formula to calculate the sum of the first n terms of an AP is given by Sn is equal to N by 2 into bracket twice A plus N minus 1 into D. One can write this in one more way, that this is the nth term. Let us denote by what? An. And this is the first term. So this is A1. So this Sn can also be written in the form N by 2 into bracket A1 is the first term and An is what? The last term. So Sn is again in one more form is N by 2 into bracket first term plus last term. This we can always check. Suppose we are adding 1 plus 4 plus 7 plus 10 plus 13 plus say 17. Then we can always see that 1 plus 17, whenever we are adding terms of AP, whichever number of terms we choose, then first plus last is how much? 1 plus 17 is what? 18. 4 plus, sorry, here I think I made mistake in writing. Here it should be what? 16. So 13 plus 3 is what? 16. 1 plus 16 is 17. Again 4 plus 13 is 17. And 7 plus 10 is also what? 17. So in general, if I write A1 plus A2 plus A3 plus dot plus AN, sum of the first n terms of the sequence, then first term plus last term is same as second term plus second last term plus is same as third term plus third last term is same as fourth plus fourth last term. This way it goes on and on. So here 1, 2, 3, 4, 5, 6, because even number of terms are there. Nothing is left because we are pairing the things first, last, second, second last, third, third last. But suppose we are getting odd number of terms. Then first, fifth, then second, fourth, then third is left. That is the only term. So add that term with itself, you are getting the total sum. For example, if I remove this 16 and we are suppose adding this much. So 1 plus 13 is 14, 4 plus 10 is 14 and only 7 is left. That is to be added with what? Itself. So 7 plus 7 is what? 14. So this always happens whenever we write n terms of an AP, then first term plus last term is always second term plus second last term. is equal to third plus third term plus third last term. This way it goes on and on. So this is all about the AP, nth term and some of the first n terms of AP.